Hello guys, my name is Michael Kenodia. My team, Chain, was working on this project, p2p energy soap. Now the problem we are trying to solve, we are having surplus solar energy wasted, up to 20% of rooftop solar generation which goes unused daily. That's roughly 94 gigawatts hour per year in Kenya, worth probably 2.47 billion Kenya shillings in potential value. We have high-end unreliable grid power. A lot of households with using the solar panels are connected to a green power, and the urban and peri-urban households will still face the frequent outages. That's like 9 hours a day, and high unit cost despite growing solar adoption. There are no efficient local energy marketplaces, so there is no trusted p2p platforms for households to sell surplus energy to nearby users. There is limited feasibility and automation. Users lack the real-time insight into generation, consumption, and optimal sell and buy timing. So users don't know the real-time generation of their solar energy, their consumption, or their optimal sell and buy timing. The solution we are trying to provide, we are tokenizing surplus solar. The households are connected to a main grid, so if a household exports energy, the program itself means a token in exchange, which is equivalent to the energy that he or she has exported, and this enables the household to sell or buy the tokens, therefore enabling the p2p trades. We are using IoT smart meters to report the real-time generation and consumption inside the household. We are having AI to recommend the buy, sell, hold, and suggested prices, which works as a crypto marketplace, where you will have the AI to predict and advise you on when to buy, to sell, or to hold your tokens. We settle payments instantly with M-Pesa SDK push. Finalize token transfer only after payment confirmation. Here is why we use the blockchain smart contracts to ensure efficient and trustworthy payment transactions. We are providing a simple dashboard showing generation, consumption, token, and balances, and trade history. Start with a mocked MVP, simulated meters, plus mock M-Pesa, then swap sandbox and maintain integration, which we'll see in a few. The key features of our program, we are having a smart dashboard where we see the real-time energy monitoring with AI-powered predictions for usage and surplus. We are having the energy marketplace where you can buy and sell energy tokens with transparent pricing, whereby we have used blockchain to ensure that there is no market fluctuation. We have M-Pesa integration, seamless tokens purchases using mobile money. We are having AI predictions, machine learning forecast for tomorrow's energy needs and surplus, which can advise you on buying and selling of tokens. So the tech stacks used in this project, you have the programming languages. You have TypeScript, JavaScript, Python, Rust, and Bash. For the front end, we used React, Tailwind CSS, PostCSS, Axios, and TypeScript. For the backend, we have Django plus DRFs, simple JWT, SQLite, Docker Compose. For AI and analytics, we used Flask API, weather and machine learning integrations, logging and telemetry. For the blockchain, we used Rust and Anchor for the Solana smart contracts, Flask minting service, optional SPL gateway. For the IoT simulations, we used Walkway, Webhook, Device SDK. Payments, we used M-Pesa SDK push, Webhook callback. For the DevOps, we used virtual environments, Grok, and Env configs. Now we get into the project. Now here is the user interface of our program, whereby on getting started you'll be redirected to your dashboard as you have signed in. Now we have the the option to send energy to the grid. Here we have the live meter here, which shows the real-time power reading from the solar panels. We have the energy flow. Here we have the token balance, the energy which is exported to the grid, the house consumption, and the net energy. This was simulated using the walkway. Here we can see we are using ESP32 and 2 potentiometers. Now for the first potentiometer, here is where we have the live meter readings. Here is where we display the live solar generation, and here is where we have the load, the household load, where we have the household consumption. So if we vary the potentiometer here, the live meter on our dashboard should update and read 1.31 kilowatts. That is the real-time power generation by the solar panel. And we can see here the household consumption is 0.0. So we can vary it here. And it updates to 1.11 kilowatts. Now we can see the net energy to 1.98 kilowatts. The net energy here is negative 0.66. Therefore we are having a deficit, meaning we have to buy tokens so that we can continue using the energy. If the production was greater than the consumption, therefore the live meter reading will be 3.65 kilowatts. Therefore we'll be having a surplus. Having a surplus, we can export energy to the grid. Let's say we want to export 1 kilowatt. Exporting 1 kilowatt to the energy grid will mint an extra token here. So we have the AI predictions for the tomorrow, that's the October 9, the expected production, expected consumption based on the historical data. Then we have the AI analysis, where it gives you, it recommends for you to hold. Then the predicted surplus. For the predicted surplus, you can list the token for sale, where you can come here and just list the token you want to sell, and you can just post it for sale. Now if you're having a deficit of tokens, you can buy from other households, where if you buy, you'll an STK push will be sent to your phone to confirm the payment. Now you're having the market prediction, where the decision of the AI for instant here is hold, and it gives you a reason. The balance usage consumption nearly matches their production. As we go on to the next tab, we have the transactions. Here is where you have a history of the transactions, the tokens minted, tokens bought, sold, and the net earned. We also have your profile. So this program works on GPS automatic location detection, where in logins the system will detect your location and it will be updated here. So what's our target audience? A target audience is households and small businesses with solar panels who want to sell surplus power or cut electricity costs. We have communities in off-grid or unreliable grid areas seeking affordable and sustainable energy access. We have local energy cooperatives and microgrids exploring peer-to-peer trading models. We are having green tech investors and NGOs supporting clean energy and digital inclusions. We are having utility companies and policy makers interested in renewable integration and smart grids. Our goals as Watchin is to empower locals to earn from their surplus solar energy through trusted p2p trading. We are lowering the electricity costs by enabling direct fair energy exchange. We promote clean energy adoption and reduce dependence on fossil fuels. We are building energy independence, where within our communities through shared resources. We are fostering financial inclusion using M-Pesa and accessing blockchain tools. So thank you. That's our project.